All right, hello and welcome. This is a quiz on access control lists. I'm so glad that you're here for the live event. If you're not, catch this in the recording. It'll be edited. And without further ado, here we go for today's quiz. All right, I'm so glad that you're here. I really, really am. I look forward to this every single week. It's on access control lists. Here is question, my friends. Question number 1. It's multiple select, so make sure you choose at least 2 answers or more if they apply before you submit. Which ACL entry, or entries rather, deny internet HTTP replies back to PC1 and to PC2? And this topology we're going to be using over and over again in this set of quiz questions. In answer to the question, which ACL entries deny internet HTTP replies to PC1 and PC2? The answers are red and yellow. Why is that? Let me get a pen out and let's talk about that together. Here's how I think this would play out. I think if PC1 and PC2 went to a website out here on the internet and they used a source port, which is like some high numbered port, let's say 32,764, whatever they had an open port, they used it, and they're going to a web server, they're going to the well-known port of TCP, that's a layer 4 protocol, port number 80. And then the response coming back would be sourced from TCP port number 80, going to whatever ports that PC1 or PC2 initiated with. So if we wanted to deny traffic coming back to these clients, we would want to block on TCP with a source port of 80, not a destination port. So deny IP any is, so this is the source, and this is the destination. And this says, when it says IP, it basically says anything. So imagine the protocol stack. We all know and love the protocol stack. So I'm not going to go to OSI. I'm going to go with the TCP/IP modified hybrid that we always use today. So there are the layers. So there's layer 1, 2, 3, 4, and the application layer. We don't ever call it layer 5. We just call it the application layer. And here we have the physical and data link and network and transport and then application layer right there. So in an access control list, if we say IP, it's going to say, great, that's anything that is, and this is IPv4, anything that's IPv4. As far as what we're looking for, we're not looking for layer 4 protocols or ports. We're just looking at, so denying IP traffic sourced from anywhere, destined to 10 to 0, anything. That's what this wildcard mask says. That would deny not just only HTTP traffic, but other traffic too. But that would cover it. Which ACL entry denies HTTP replies to those 2 devices? Red covers it because that denies everything. It's grossly over filtering. However, it would deny it. And then the other answer here is deny TCP traffic from anywhere if the source port equals 80 going to anywhere. So if you divide this here, everything on the left is talking about the source, and then over here on the right is talking about the destination. And that's why blue isn't correct. This would be if we're going to a web server to the destination well-known port of 80. And over here, same thing, same problem there. So these 2 are the correct answers. You can join me for my office hour every Saturday at 10 a.m. Pacific. I'm happy to walk through these and chat with you about them. Also on the Discord server, we have several thousand people strong, maybe 7,000 or 8,000 now. And you're welcome to join us there, post questions, and really get to understand how access control lists work and function for the benefit of filtering. Which ACL entries permit DNS requests from both internal networks? Now, the internal networks here are 10.2.0 and 10.1.0. Those are the 2 internal networks that I'm talking about. Good luck, everyone. Okay, which ACL entries permits DNS requests from both internal networks? Well, let's take a look. A DNS request, if we're looking at a DNS request from the 10.2 network and the 10.1 network, that would be going out like this if the DNS server is out in the cloud, like a public DNS server. And the DNS request would be UDP based. A DNS request is always UDP based. Now, I know somebody like 20 years ago wrote in a book that, hey, DNS is TCP and UDP. And it is true also that some DNS functions use TCP, like a zone transfer, but that's way beyond the scope of CCNA. For CCNA, I want you to think about DNS as in DNS requests, resolving names like bubba.com to an IP address, and it's always UDP at layer 4. And the well-known port for that is 53. So DNS requests from 10.2 or 10.1 anything, or 10.10, 10.20 anything, with the destination port of UDP port 53. So my goal here with these questions is to help us confirm that we understand how it works. And then, like in certification, if they ask you about how something works and you know how it works, guess what? Boom, you're done. You can just like, oh, I know how this works, and ask me a question about this. And you're like asking the exam to ask you a question. And it's going to ask you some questions that measure your ability to understand how it works. So that's why I include them here. All right, so we go look back at the answers. Permit UDP down here in the bottom left. Permit UDP, that's a great start. And then the wildcard, the network is 10, okay. 10.0.0.0 with a wildcard mask of these 3 octets on means it only has to match on a source address of 10 anything, which covers 10.2 and 10.1, going to anywhere if the destination port is exactly equal to port 53 for UDP. And that's why this answer here is accurate or correct. And then the bottom right hand, green, says permit UDP. Again, a good start. This says 10 anything based on the wildcard mask. And going to host 8888, which is, you know what, that's a well-known IP address that's a very common IP address for a Google DNS server. Going to the well-known port of 53, that's why that one's correct. And the reason that this isn't right here is because this part is saying what the source address, I get my colors mixed up here. So this is saying that the source port would be 53 instead of the destination port. So the source port from Bob's PC or PC1 is going to be some high numbered port that's currently not used on that computer, like 33,948 or something. And then that'll be the source port, not 53. And then it sends it to the well-known port of 53. And then the response will come back from the server using the source port of 53 back to the destination port of 33948. So that's why this one's not correct. And this one, permit UDP any equals 80. 80 is the well-known port for HTTP, not DNS. And also HTTP is using TCP as well instead of UDP. All right, so that's the scoop there. Good work to everyone. I'm glad you're all here. Here's question 3 of 9. Multiple select. Make sure you choose at least 2 answers before you click on submit. Which NAT access control entry, or entries rather, allows PC2 to be translated? They are all good answers. Good job, everyone. Which NAT ACL entries allows PC2 to be translated? And so what we need to do is identify what is the source address of PC2. And I think PC2 is down at, I can look at these answers. PC2 is 10.2.0.50. And so if that's PC2's address, our access control list that we use as part of NAT or PAT needs to make sure we're including that range. So permit 10.2.0 with a wildcard mask. Let me change my color there. Of this, which means that source address is 10.2.0. That matches. That's correct. Permit 10 with a wildcard mask of 3 octets we don't care about. So that has to match. It does. And then permit 10.2.0.0 with a 2 octet wildcard mask, which means we're matching on that, which it does. And then permit host, that basically says the full 32 bits match, and it does. And then we could also write this one as permit 10.2.0.50 with a wildcard mask of 0.0.0.0. It says the same thing. It's just matching on all 32 bits, and all 4 of them are correct. And look how good you did. Oh my gosh. I'm so pleased. Crushed it. Nice work, everybody. Now, a couple of tips here. One is the faster you answer correctly, the more points you get. And you're a winner if you just showed up and put in the effort. That's the secret also. All right, here's question, I believe it's number 4. Yes, it is. Question number 4, multiple select. Once again, double points. Uh-oh. ACLs are intended to block FTP to the internet, but they're not working. Which of these answers could cause an ACL to not be functioning correctly. So ACLs are intended to block FTP to the internet but aren't working. What could cause that? Well, if we don't apply the ACL in the right direction, that's not going to stop anything. If the ACL is applied to VTY lines, that'd be fantastic for things like restricting SSH and Telnet to that device, but it's not going to apply to FTP being routed through that router to the internet. The ACL is not applied to the correct interface. That's absolutely a showstopper. And ACL entries are not in the correct order. And that means this: if we have a permit statement at sequence number 10, and then 20 we have a deny for something else. So deny A and then deny B. If in this permit statement is too broad and it's matching, as that access list is being processed for a packet, it looks at sequence number 10, says, oh, permit. And if there was a deny, let's say it was, for this was deny IP or permit IP any, this is way too broad, but just as an example, permit IP any, that's going to be, everything matches. And then anything you deny after that is never going to get to 20 because the permit IP any is too broad. So if you have an access control list sequencing issue where your initial statements match before the ones that you want, you might need to reorder or rearrange your access control lists to make them behave the way that you want them to. Aquatic bear. Wow, not letting go. Flying unicorn giving us a run for the money. Legend mouse, magic fox, and aquatic koala. Oh, that's clever. All right. And magic squid is the highest climber. Lots of good competition going on. All right, we're halfway through. Here's question 5 of 9, multiple select, double points to prevent SSH, secure shell, from the 10.2.0 network going to R1. What may be used? All right, to prevent SSH from 10.2.0 from that subnet going to R1, what may be used? And here are the answers on the board that are correct. And R1 could have lots of interfaces. It could have loopback interfaces. It could have physical, like gig 0/0, 0/1. And it could have IP addresses on all those interfaces that are reachable. If we went into line VTY 0 space 4, that's the 5 default VTY lines that people logically connect on when they're telnetting or SSHing into a device. If we went into those and we used the access class command, we could restrict with an access control list who is allowed to try to connect on these VTY lines. That's why this is true. So good job to everybody who voted that. A named ACL, sure. Standard ACL, numbered, named, either way is great. So you could use a named ACL if we wanted to. That's, again, fantastic. And access group is also correct because if we had an access list that we applied inbound on one or more interfaces, we could go ahead and filter traffic based on the access list that's applied for packet filtering as opposed to VTY access filtering. So that's why these 3 answers are correct. This is question 6 of 9. Multiple select. Which ACL entries, plural, deny SSH from PC1 trying to go to the server? Good luck, everyone. Yeah, wow, look at this. Which ACL entries deny SSH from PC1 going to the server? Wow, that's great. Let me just peek at the topology real quick, and then I want to confirm the answers. Looks like we did fantastic on that, though. So if we wanted to stop PC1 from SSHing to the server, we have several options. We could have an access control list inbound here on gig 0/3 or 0/3, whatever the flavor is of that interface. We could have the access list applied outbound here. That would work. And then we have to match on the protocols. So this client, if we're doing an SSH session, it's going to be using TCP, and the source port would be some high numbered port, because the PCs, they just look in their memory and say, what ports do I currently have open? And it'll choose a currently unused port, and the destination port would be port 22. And then the IP addresses, unless we're using NAT, would be the source IP address here of 51 and the destination of 10.1.0.100. So if we take a look at the answers, I'll just clear that off real quick. And just confirm that the answers are, it says all these are correct. Wow, another one with all correct answers. Deny TCP traffic from 10.2.0. So this this wildcard mask says we don't care about this last octet. So the source has to be 1020. The destination is 1010 The host keyword says match on all 32 bits. Just a faster way than doing 1010 with 4 zeros for wildcard bits if the destination port equals 22. So that is spot on. Let me change my color here for a moment. And then deny IP host 102051. Okay, all 32 bits going to all 32 bits. That's definitely accurate. And then deny IP traffic source from 1020. The wildcard bits here say we don't care about matching on the last octet. So that matches the source address. And then over here we have the destination portion, which is 10100 with a wildcard mask of 255 saying that we're going to deny anything going to 1010, which that's the client. So the client's coming from 1020, and IP says anything in the IPv4 protocol stack. Doesn't matter what layer 4 protocol is using. If it's going from 1020 to 1010, forget about the last octet, that's a match, and as a result, that's a correct answer for denying SSH. And then finally, deny TCP traffic at layer 4 from host 102051, which is our PC1 address, going to host 1010, the server address, if the destination port is exactly equal to 22, which it is. All right, all those answers are correct. I was going to say don't shoot the messenger, but yeah, you can shoot the messenger. I wrote these. But I wanted to have us think about every single question that comes up about how it works. Because in real, I can still remember in the early days, like back in the early 2000s, which I know was a long time ago, could be 21 years ago based on when you're listening to this video. But when I started learning the technology and then applying it, I was like, oh my gosh, this actually works. It's like, yeah, it works. And it's even better when you've studied on how to make it work. And so these fundamentals are critical. And I would encourage you to have fun with it. Networking is fun. It's fun. And sometimes when we're new to something, it may take a little bit of a ramp up. But doing hands-on practice with Packet Tracer and just having fun with it, it's totally worth it. And these skills are totally worth it. And they're going to help you in your career. And they're going to help you troubleshoot almost everything as far as networking goes by learning the fundamentals, including access control lists and how we can apply them. All righty, let's go on. Here we go. Here is our 7th question. It is multiple select. IP filtering ACLs can be applied in the same exact way to which of these following interfaces? Now, only choose the interfaces where we could apply an access control list for the purpose of filtering. What? No, Keith, you can't do 3 or 4. You can't do 3 or 4 quiz questions where all the answers are correct. Yes, I can. And the reason I'm doing it is because I want to find creative ways of getting you to think about what is possible and how it works. And so let's just take a look at these together. Let me move my face up here. All right, as far as an access control list for filtering, we could apply it to a layer 3 port. So on a switch, we could use the command no switch port on a switch port on a multi-layer switch, and that makes it a layer 3 port. At that point, it's just like a routed interface on a router. So we could apply an access control list there as well. A router interface, yes, definitely, positively. An SVI, a switched virtual interface. And when you think of a switched virtual interface, if I could have been in charge of naming that, I would have called it a routed virtual interface because it's a layer 3 interface. Like on a multi-layer switch, you say interface, let's say you have VLAN 10. And you have 20 people in VLAN 10 or 100 people in VLAN 10 on access ports. How do they get off the VLAN? They need a layer 3 interface that they can point to as their default gateway. So if you have a traditional router in that same VLAN, that'll work. Or you could just create a switched virtual interface, a layer 3 interface for VLAN 10, give it an IP address, and then point everybody to that IP address as their default gateway, and you're good to go. So switched virtual interfaces is definitely a layer 3 option for applying an access control list. And then IP sub interfaces if we're doing a router on a stick, which we don't do very much anymore. But in the old days, it was like, woo, router on a stick. Now it's like, router on a stick. Interesting concept, but we don't really need to do it too much anymore because we have multi-layer switches that have routing capabilities built in. All right. Fantastic work, everybody. Let me clear the screen. Right after the quiz today, in the Discord server, we're going to hang out in the CCNA voice chat room, and Kelvin, who's the admin on Discord, is going to demonstrate some BGP, some big gory protocol, Border Gateway Protocol, and some of the basics of how it works. If you want to join us for a BGP discussion, that's a great place to do it. Okay, here we go. Moving forward. Oh, man. Let's see. Flying Unicorn, first place. Flying Lizard. Wow, we have 2 flyers. Nice. All right, here we go. Question 8 of 9. This is a poll. How many online quizzes have you watched or participated in live? I am curious. All right. Okay, good. I am so glad if you're just new to the channel. My name is Keith Barker. I'm at double CCIE. I've been one for a long time. I love tech. I do. And I also love entry-level tech. And my goal on YouTube is to help as many people as are interested in helping them get their CCNAs. And so I encourage everybody to get a full course of study, whatever that is, that covers every bullet on the blueprint. And then to reinforce those concepts and to help understand those concepts, use this channel, Keith Barker, on YouTube to, the quizzes and the discussions and the Discord channel. They're all free. And the office hour is every Saturday at 10 a.m. Pacific. Quizzes are 11 a.m. Sundays Pacific time. And take advantage of the resources. It's interesting that I opened the floodgates for the office hour. So if people want to come and chat with me or talk with me, you can DM me directly on Discord and I respond. Sometimes it's a couple days because I queue them up and I spend some time focusing on it. But I'm accessible. I'm here for you. If you are here and ready to put in some time and effort in learning these technologies, which very likely are going to change the trajectory of your life in the world of IT and networking, I'm interested in helping you with that if you're interested in putting in the time. So I'm available. Take advantage of it because I'm happy to do it. All right. And thank you very much for all your participation in these quizzes. That's good to know. Also, the entire quiz playlist is at this URL. You can go to ogit.online/quiz. And that is the URL for the playlist. So you can check out all the videos, all the playlists, all the videos for the quizzes. They're all right there at that URL. Which ACL entry blocks HTTPS replies to both internal networks? Now I'm talking about 10.10 and 10.20, both with the 24-bit mask. All right, which ACL entry blocks HTTPS replies to both internal networks? And I'm a visual learner by default, so I like to, at least if I'm not going to write it out, I'll at least visualize it in my mind. I can just think of like one user, like Bob, and one server, HTTPS, and I just think, okay, if there's a conversation between Bob and the HTTPS server, they're going to start off with a 3-way handshake with a SYN, a SYNAC, and an ACK. So they've got the session set up. Then they're going to set up HTTPS, which involves client hellos and some other cool stuff, and sending digital certs and all the other kind of cool stuff that happens behind the scenes. But the ports involved is what I want to talk about here. So client Bob is going to use some high-numbered port like 12,428 or something as a source port, going to the well-known port TCP port 443, which is a well-known port for SSL/TLS. Now today, most secure websites are using the TLS flavor of security with TLS 1.2 or 1.3 and no longer using the weaker SSL. But sometimes they call it SSL, and what they really mean behind the scenes is some kind of HTTPS anyway. All right, so those are the ports involved. So which ACL entries blocks HTTPS replies? So the replies coming back, let's focus on that for a moment. In fact, let me put that in a different color. The reply coming back would be sourced from the port 443, going to, in this case, Bob at 12.428, which we can't really control what that port is going to be because the client just picks it out of thin air when they make the connection. So let's see why green is correct. Deny TCP traffic at layer 4, TCP, from anywhere. Okay, so that includes any HTTPS server. If the source port, again, this is on the left-hand side before the destination IP address, if the source port equals 443, which it does, and if the destination is 10 anything, so the 10, when this wildcard mask says, I don't care. Actually, in an ACL, they're referred to as wildcard bits. When we use them in a network statement, they're considered a wildcard mask. But in any case, these 3 octets of wildcard bits say we don't care about the 2nd, 3rd, and 4th octet. So now any traffic coming from anywhere with the source port of TCP 443 going to 10 anything, which includes Bob's network, and which he's on the 10 networks, 10.2 I think he's at, that would block it. And that's why this green answer is correct. And all the rest, we could go through all the rest as well as why they are not correct. But in the recording, if you want to go back and look at this, you can. And if there's questions, come see me in the office hour and we can discuss it. Also, if you are coming to office hour, queue up your questions. You can do that on the Discord server. There's a spot in the office hours where you can post your questions. And that way, every Saturday at 10 a.m. Pacific, when we get to that, I can just pull those and start answering those questions. Also, I want to offer to anybody who's interested, if you are getting ready for your CCNA exam and you have a few people usually know where they're strong, like, oh, I know this topic. You know what those are. Like, I know how ARP works, or DHCP, or DHCP relay, or OSPF, or what has to match for OSPF neighbors, or access control list, or authentication. The list goes on. There's 6 domains in the blueprint. If you want to have me not challenge you, but ask you some questions about some topic that you want to confirm that you're ready for, hit me up. So I've done several of those where sometimes I do it private one-on-one, just like for a half hour. We carve out a half hour of time and just do it privately. And sometimes if you're open to it, we'll do it publicly where we'll just invite the whole world to join us and it'll be just you and I confirming. But to do that, I want to be very clear. To do that, I'd love you to be ready to say, okay, this section or these questions, not these questions, but these sections of the blueprint is what I'd like you to test my knowledge of. And there's 6 domains in the CCNA blueprint. And if you have questions on certain bullets, bring them. Meaning, I think I'm ready, just want to confirm, and I will help you. Just like these quiz questions can help us identify what we're good at or not quite ready for, I'd be happy to do that if you're happy to invest the time. And then we could share it on Discord. It would not be recorded. It was just for people who show up for the live Discord event, and I'd be happy to do it. Okay, so that offer stands, and I'm willing to do 1 or 2 a week for a half hour, an hour. I'm happy to put that time in, and again, that's free if you're interested. So let me also tell you what to not do. Let's take a topic like DM VPNs. Yeah, so that's not on the blueprint. Use it as an extreme example. Let's imagine that you wanted to learn about DM VPNs, dynamic multi-point VPNs, which are super cool, by the way. And let's say you're studying it, or you needed to study it, and you show up and say, Keith, can you teach me everything there is to know about DM VPNs? That's not the best use of either of our time because there's so much content out there regarding the basics and fundamentals. So to really leverage our time together, you'd want to study something first. And then if you still have like questions or concerns about how it works or to confirm, that's when I can bring additional value and help, point out the details of, oh, it's this MAC address, or this is how it works, or here's how it doesn't work, or whatever. So anyway, just use me as a resource when you've done a little bit of study. That's all I ask. And that way I don't have to explain something like, I don't mind explaining ARP, right? I don't. However, I've got like 150 plus videos on my YouTube channel just in the CCNA playlist that cover lots, in fact, most of those basic concepts. So please leverage those first. Having said that, let's take a look at the winners table. I think this is the end of the quiz. Also, right afterwards, here's the podium. I'll be quiet for a moment. Here we go. All right, Flying Unicorn, you did it. 8 out of 8 questions correct. Way to go. Way to go. Here are our toughest questions as well. This is valuable for me as a trainer to help understand where we can improve. Wow, look at this. So this shows the toughest 4 questions. So this one question number 3, we had 4% correct. Question 6, based on the lineup, 16% correct. And it gets a little bit better after that. So a little bit of room for improvement, which is great. And also, I'd love to get some feedback if you would be kind enough to go ahead and provide some feedback. And I also want to thank Harmon again, and for both the sticker just now and also for helping me proof this quiz earlier today. Also, Soren, thank you very much for the sticker. That's very kind of you. And if you're up for it, let's do this. Let's spend a few minutes. If you have questions for me specifically, I'd be happy to take a few minutes right now in this live stream. Oh, also, let me say goodbye to everybody else. So as far as the edited version of this live stream, I hope you enjoyed it, and we'll catch you in the next one.